Question 12. Question 12. Find all relative extrema. Hello.
Sir, sorry, can you kindly go back to the previous page?
Yeah. So find all the relative extrema. Use the second derivative test where applicable. So you only use it when it's applicable. Are you done?
Yes, sir, thank you.
Okay. So question 12a, f of x is equal to x plus 4 over x. You can write this guy for the sake of differentiation as 4x to the power negative 1. And then to find the extreme points, we use the first derivative. So we differentiate this function. F prime of x is going to be 1 minus 4x to the power negative 2, which is 1 minus 4 over x squared. From there, we equate this to 0 for us to find critical numbers. Remember there's a question where you're finding critical numbers. So you get the first derivative and then differentiated it. I mean, you get the first derivative and equate it to 0. So here we have 1 minus 4 over x squared is equal to 0. 1 is equal to 4 over x squared, meaning 4 is equal to x squared, so that x is plus or minus 2. So we have two critical numbers. X is 2 and x is negative 2. So these two numbers will give us a turning points, will give us a turning coordinates for the function. And those turning coordinates are what we refer to as extreme points. So go to the function and take the corresponding values of these guys. What is f of 2? F of 2 is 2 plus 4 over 2, which is 2 plus 2, which is 4. We get f of negative 2. We have negative 2 plus 4 over negative 2. This is negative 2 minus 2, which is negative 4 in the original function, so that we get the full points 2, 4 and negative 2, negative 4. The question is, these are the extreme points, of course. Now, what's the nature? Is it maximum or minimum or inflection? So to know whether it's maximum or minimum, we've been asked to use the second derivative if possible. So we can write this first derivative as 1 minus 4x to the power negative 2 for easy differentiation. So let's differentiate the first derivative so that we get the second derivative. We're going to differentiate the first derivative. So it will give us the derivative of 1 is 0, of negative 4x to the power negative 2 is negative 4, negative 2x to the power negative 3. So that we get 8 over x to the power 3. Now this one, then you get the critical number if the second derivative will give us a positive here. Then we're going to call the point minimum. If the second derivative for this number will give us a negative number, then we'll call this maximum point. Okay, so let's substitute and see what we get. What is f prime prime of 2? It's 8 over 2 to the power 3, which is 8 over 8, which is 1. 1 is greater than 0, so this point is called the minimum point. Okay, then we come back the second derivative and substitute -2. We'll get 8 over -2 to the power 3, which is 8 over -8, which is -1 less than 0. So this point is the maximum point. Now, because we have not sketched, we're not so sure whether it's really the minimum or relative. Okay, or relative. What do we mean by relative? If you have a sketch, you have points 2,4, 2,4. You have a point there. Another point is -2, -4. So if the sketch with the y coordinate being 0, so if the sketch has these turning points, we can think about it to be in this manner. You can think about it to be in this manner. So we say a relative, maxima because it is the maximum, yes, but there are other numbers that are bigger than it from the function. It is minimum, yes, but there are other numbers that are lower than it from the function. So it's not the extreme minimum, but a relative minimum and a relative maximum. Unless cases where you sketch your function, it comes out to be maybe something like this, where you have this point equal to that one. So there's nothing higher than those points. That's when we say what I have is the minimum point, the extreme minimum or the extreme maximum. And this one will still remain relative. Okay, so I understand that you have another, we have a lecture at 7, which was called to be 6:50. So we end here. I will send the recorded in the group. Have a good day.
Same.
So
Thank you, sir.
Okay.